Hi guys. I'm just talk about the. Wait, hold on. Oh yeah. Today the main topic is that the like last video I just talked about like scheduling thing, and this the main topic is explain something like of our software, some software using like what I learned, which is scheduling. If you I'm doing some kind of side project, which is that those kind of app development, desktop app development. I'm gonna use Electron TSX. The reason I'm just gonna use Electron TSX is because I don't want to so go deeply about like making some kind of app development for like unnecessary framework. I can use Vite debundler and Reg for making some kind of like the desktop application. If I try to use Electron, I can make it. But the thing is that if you're trying to look at the web application, you're able to hear about some kind of performance, how to enhance the performance of your website, and but in Electron based that's the application, I don't think that's kind of really same with your normal website, because basically what Electron does is if you look at the UI, it's just gonna use Chromium for the UI rendering. So but if you look at how Chromium works, the Chrome is actually multi-process application, and it only uses the one thread in render process. So all HTML, CSS, JavaScript is gonna be rendered in one thread in the render process, which is the main thread. Everything is gonna be happen. But if you look at let's say if you're trying to make some kind of app using Electron, and you have to open some kind of Electron process of it, using Electron and open some kind of render process. And I think that if you look at the perspective of on the rendering in that's the application, the CSR, those kind of rec thing, I think is gonna be like effect on the, it could be effect on the performance, but I'm not sure about this, because if you look at our Chrome website, if you're a browser, your website is actually part of your current Chrome tabs. There are multiple tabs in your browser if you're trying to open it, and there's some specific website that you're trying to look at it is gonna be handled by the another process. So your tabs is just the process per tab, and that is really using the render process. If you look at the scheduling perspective, those kind of scheduling, we're just gonna like schedule those kind of process. But if you look at your current website in your browser current tab, the process is gonna be only handled by in this part while you're looking at it, rather than other website in your tab. So even though you enhance those kind of like performance in your website, it's not gonna be a really big issue. It's gonna be like not that big, because if you're trying to open some kind of other tabs in your Chrome website, and even though you enhance your website in your current tab, it's not gonna be really big for performance if you're trying to put some kind of lot of tabs in your browser. But if you look at the Electron, there's only one tab, which is your UI of your application. So if you're trying to enhance the performance, example SS using SSG on the root rather than using the CSR on the root on the auto of it, because what the CSRs do is it just telling the JavaScript, hey JavaScript, I know making HTML from the scratch is really kind of like tedious, so I'm gonna let you train to render whole of the website my view using JavaScript. This client rendering is just only like dummy HTML, and JavaScript is the one who trying to render sort of thing. If and also if you look at the perspective of like scheduling thing, if this thread is longer and heavier, the scheduling problem, if you look at the operating system scheduling problem, is gonna be late. So I'm just gonna have to reduce it. So how to reduce it? If you look at the HTML parsing, if there's more HTML parse and less JavaScript, it's gonna be more better, because normally we make some kind of JavaScript but there should be dynamic import, and if there's making this thread longer is going to impact on your operating system scheduling. So I have to reduce this kind of like those kind of rendering logic of it. So I have to reduce it. So what I have to do is like enhance the HTML using or SSG, or using SSR could be good, but I'm not sure, because making SSR means that you have to open your socket in your desktop application, but I don't think that's gonna be a really good issue, and I don't think that's gonna be like really good for your desktop application, because it's basically making more process, and because the socket is it's just doing some kind of IPC in your desktop application of it. So I think I'm not sure about this kind of stuff, but if you look at the scheduling below, I think the best way I have to reduce those kind of application performance, like enhance application performance, is reduce this kind of unnecessary rendering, because what a JavaScript, because if there's more JavaScript, there's gonna be garbage collector, and there's gonna be like more latency on the thread, and there's gonna be issue on the operating system, because what this scheduling does is it just make process into like it just schedule the process ready, and it's going and terminate. So I think I'm just gonna wrap the SSG, and inside that I'm gonna put a CSR on it, and I'm just gonna put Chromium, and I can make some kind of like Node.js server or node fetcher that communicates via IPC, but I'm not sure it's gonna be working on that. So this is it. Have a nice day. See you next time. Bye bye.